Hey, welcome to part 2 of our episode about vector databases. We're just about to join Uli as he takes us in a different direction.
Okay. So we talked already about embedding, which already is a very sophisticated technique. Good news is that all of the LLM teams have now technology and tools to make it easy to bring vector stores, vector databases into your models through embeddings. Again, that's true for Azure, that's true for Google, et cetera, et cetera. So if you want to do that, make sure to use the right tooling to help you. But before you go there, you can effectively use prompt engineering to also feed example data, what you're looking for, to the model. So part of the prompt engineering is what's called one or multi-shot training. So what you do is you effectively, as part of the prompt, you're saying, I'm expecting this kind of output. Then the system actually takes that into account and says, that's what you're looking for, and responds in kind. And you can feed quite a lot of data into it to say, hey, take a look at this sample data. This is what I want you to look at. And that's obviously far cheaper than doing embeddings and other things because it's part of the prompt, and therefore should be always considered first before you go into things like embeddings. As a corporation, obviously you will end up in things like embedding, but you should start with one-shot and multi-shot training because there is a lot of knowledge in those models that can be coaxed out if you give it the right prompt.
Okay, cool. Okay, so now let's go to fine-tuning. What is fine? I mean, you would think that fine-tuning would be, I'm just going by its name, right? But I suspect there's more to it than just like, the name. What do we mean by fine-tuning in this context against those other things we've just discussed?
So fine-tuning, and again, I am an architect. I am not a LLM developer. So I only have to go by what my incredibly deep peers have educated me on in the space. So fine-tuning is the way in which you take a model and you try to develop a fit-for-purpose data set. And whether it's a pre-compiled model that you've downloaded or used or has been already trained, you engage in additional training loops in order for it to train on a fit-for-purpose data set, so that you can basically tune it to respond in the ways in which its purpose is to respond. So it's basically taking fine-tuned data sets, and that's one of, from what I understand, of many ways in which we do it. But the fine-tuning element is to adjust the model's parameters based on iterative training loops around purpose-driven data sets.
Yes, that's really the key part, where you bring specific data sets and you take a layer of the model and train it. So it's really adding more constraints to the general purpose model. And it's using your data to effectively train itself to say, you're in the healthcare domain, or you're in the industrial automation domain, or wherever you are. And bringing the right data will help the system understand, this is the type of output I'm looking for. And fine-tuning also helps extremely with hallucinations, because you tell the system this is what you need to pay attention to, and it will effectively adapt and be more precise.
Okay, so this makes sense. I mean, I think that some of this came up in our conversation when I was saying that I was working with some people that were trying to take existing structured data that we had and use LLMs around it or with it or next to it and that sort of stuff. And that was a lot harder than I was anticipating. And the reason why I think we're bringing this up in the land of armchair architects is that, congratulations, these are some of the tools that we're going to be asked to architect into systems or to be part of systems that we're building. And if you don't understand what the possible things are in the toolbox and you reach for the spanner wrench when what you really needed was the screwdriver, you're going to be doing a lot of like banging at the thing you're trying to move. I hope that the world of structured data becomes more, or whatever. That my particular problem was, we had an existing structured data set, and I thought, oh, this will be cool. I'll just tell a large language model, go off and use this. And it turns out not so much.
Yeah, so I would say, first of all, there are two things that large language models are really bad at. Math. So don't ask it to do calculus for you. That's not going to work. And the second one is you can't point today, at least, a large language model to a structured database and have the system just automatically understand, this is the schema, this is the data, and here you go. That's something you need to do some work on. And the state of the art right now is that you effectively build shims around it. So you write code that you can then integrate into the prompt. For example, OpenAI has a way for you to call a function inside your prompt. And that function can, for example, bring relational or bring structured data back. Remember the shot training? You can effectively take the result set and feed it into the prompt. Obviously, you need to make sure that the result set isn't too large and stuff like that. So there's a couple of those things. And then there's also, let's call it pipeline-based programming, where you simply say, step one is, let's take a concrete example. You're an insurance company, and David is my insured person, and you would like to understand your claim status or something like that. So you go into the website, you do it, you type in the chat, and the first thing that I need to know is who is David, and my CRM system will know that, and they will know what insurances you have, what claims are open, all this other stuff, and that's all structured information out of a CRM system and maybe a claims management system. So the first phase is you parse the language, the text that David entered, using GPT, for example, and get you pull out the information that's relevant, and then feed it through structured API calls. You get the result sets back. You then create the prompt that you really want to use for the response. Again, using prompt engineering with the one and multi-shot training. That's why that stuff is so important. And then the system generates the beautiful response that you're looking for, in terms of, oh, hi, David, great to see you again, blah, blah, and here's the state of the claims, and so forth. And you effectively use the OpenAI model in this case twice, not just once. You use it first to understand the language and extract what you need to call the structured APIs, and then you feed the response from the structured system back into the prompt so that it generates the response you're looking for.
So I dig this because this is getting into sort of like what we have to really understand, how it really works under the covers. And I think that's really good. We're going to be talking about that in the next episode, right? We're going to be getting into sort of domain specific LLMs and how do you handle orchestration sort of stuff. It looks like you want to say something about that, Eric, before I cut us off and say, join us in the next one, because that's exactly where we're going to go.
Yeah, so I want to basically summarize, because the topic is vector databases. So those architects that are like, how do I figure out whether or not I need a dedicated vector database, or I can use these things called vector search indexes, or how do I build a system so that I can help LLM developers be better at their job or more efficient at their job? So I think that we're reaching a transition point in which vector databases used to be an RDBMS for vectors and answering queries associated with vectors. I think what we're seeing is a lot of the lakehouse platforms adopt and traditional database management systems adopt vector indexes, so that we don't actually have to pick the data up and move it to another specific place and vectorize it and store it. So now we have these these components of relational database management systems or lakehouses that actually create vectors on top of where the data lives. So on top of Delta tables, for example. So that's one architectural consideration, and it should make architects happy, because the heaviest thing in the world to move is data, and we hate doing it. The other architectural consideration is, how do you actually arrive at the vectorization? Is it an ETL schema on write operation? Is there logic associated with the vectorization themselves? And so all of that information has got to be important to consider when you're trying to create a platform for your organization. If you're creating your own foundational models, vectorization and the process by which data becomes vectorized, if you will, or embedded, becomes super important. You also have to worry about whether or not you're allowed to store specific information based on your industrial vertical, financial services, life sciences, health, all those different things. You may need to scan and tokenize your data as well before it goes into the vectorized process. So those are all I just wanted to put a bow around some of the architectural considerations around vector databases as fuel for AI and ML and LLMs.
Yeah, so one other consideration for architects to think about is vectorization is obviously a key technique. But we have now seen data, real data, from, in this case, Microsoft, but it doesn't really matter, that vectorization is not necessarily alone the answer to the question. So we have seen that a search index plus vectorization is actually faster and more reliable from a response perspective for an OpenAI system than just the vector or just the query, the index. And so you should be much more flexible in this case, where you say, hey, how am I going to go and get this data? And sometimes it's a combination of techniques, not just one technique. As I think we have talked about many, many times, architecture for me is a understanding of the tools that you had and really picking out what it is. And ideally not looking for black or white answers, as the world is mostly gray. And really picking the right tools together makes the right answer, rather than this is the answer or this is the answer. Those things generally I don't really appreciate.
Well, I know that some of the viewers are like, oh, they're just getting into the weeds. They're just getting into the details and their stuff. And I'm going to be really mean and say that's true. And if you want to hear more about that, you should join us in the next episode of Armchair Architects here on the Azure Enablement Show.